How are you doing tonight?
I'm pretty good.
Good. All right, what do we got going tonight?
Okay, so something we were doing earlier today that I didn't really get the hang of. We were doing, it was like, I think solving inequalities with 3 equations instead of 2.
Okay. Go ahead and give me a problem and we'll work it through.
Okay, so I think it was 1a plus 2b plus 3c equals don't remember what it was, but
Okay, if it's a number,
it was.
we can't solve that. If I put in any number I want there, we have 1 equation and 3 variables.
Right, and then I'm sorry. The next equation was I think 2a plus, or no, minus.
All right, we're gonna need it exactly. In other words, if you're just making it up off the top of your head or trying to remember it, we're liable to come up with 3 equations that don't solve.
Okay. So yeah, I was just trying to remember it,
Okay.
but
I can probably find one if you want
okay.
to figure out how to do. Let me look in my book. It's better if you have the problem, because that way we'll know that we're working on the level of difficulty that they're doing in your class. The problem with me finding the problem is it may be more or less difficult than the degree of difficulty you're dealing with. And also, these are equations, not inequalities. You mentioned something about inequalities.
Yeah, that's what I thought they were.
An equation is an equal sign. An inequality is either that, or that, or that, or that.
Okay, then there were equations.
Okay. So you're basically been given a system of 3 equations and 3 unknowns? Or are you into linear programming?
I don't know.
Okay.
They were 3 equations, and they had the solution.
They were definitely equations. They weren't inequalities?
Yeah.
Okay. Then it's not linear programming. Here, I've found some here. They're not terribly easy to make up. Okay, here I got one. All right. And the methodology for solving them is very precise. In other words, you want to memorize it exactly. It doesn't matter what the variables are called.
No, I don't think so.
No, I'm saying it does not. They can be A, B, or C, or X, Y, and Z, or whatever. What we're creating here is a system of equations and different variables. In other words, there is a solution for x, y, and z based on these three equations. Now, let's talk about the best way to get it. Do you know how to solve two equations and two unknowns? Let's go through an example and make one up.
Okay.
All right, there's two variables and two equations. As long as you have the same number of variables as you have equations, you generally can solve it. And the best way to solve this particular problem is by elimination. Okay, you should have learned two techniques for solving a system of equations. One is elimination, the other is substitution. Does that ring a bell?
Yeah.
Okay. When the equations are in standard format, which both of these are, then the way you generally want to solve them is by elimination. And elimination is exactly what it says. We're going to eliminate a variable. Okay? Now, you can always, no matter what equations they are, you can always add or subtract equations. In other words, if I have a plus b equals c and x plus y equals z, there's two equations, well, I can add those together so that a plus b plus x plus y equals c plus z. You can always do that. You can always also subtract equations. So I could subtract a plus b minus x plus y, and I have to subtract both sides of the equation. Okay? So that's a key principle in solving a system of equations, is the fact that you can add or subtract equations. You just have to add all the terms on the left side of the equation, and you have to add all the terms on the right side of the equation. So with this particular two equations, equation 1 and 2, if I were to add these two equations, what would I get?
So, 5x, and then y's would cancel out, I think.
Okay.
And b equals 30.
Okay, so x equals 6. And now, in other words, by eliminating y, I was able to solve for x. Once I solve for x, I can go back and substitute it into either equation and then solve for y. Well, if x is 6, then 2 times 6 minus 3y equals 10. So minus 3y equals minus 2, y equals 2/3. Okay? So that's how you solve a system of two equations and two unknowns. Now, if, let's just, for example, say I make this a little bit of a tougher problem by doing that. Now, I cannot add these two equations or subtract them and eliminate a variable.
Okay.
However, principles of algebra allow us to multiply both sides of an equation by anything I want. So if I multiply equation 1 by 2 and multiply equation 2 by 3, and I can multiply them by anything I want as long as I do both sides of the equations, Well, notice what happens. My new equation 1 becomes 4x minus 6y equals 20. Second equation becomes 9x plus 6y equals 60. Now I can work with the new equations 1 and 2. In other words, notice that if I add these together, the y's disappear. In other words, I can get a variable to be eliminated. 13x equals 80. I can solve for x. I can go back, plug that in, and solve for y. So even if the two equations are not particularly conducive to eliminating a variable, you can manipulate them around so that you can. So no matter what two equations you give me, if you give me two equations and two unknowns, I can solve it. Always. Okay? So let's look at 3 equations and 3 unknowns. The way to handle these is to choose a variable to eliminate. In other words, I've got equation 1, equation 2, equation 3, and I can work with any two of those equations and eliminate a variable. Okay? In this particular case, I'm going to choose to eliminate the x variable. So notice that I can't eliminate it immediately. But what happens if I multiply equation 1 by negative 2?
You would get negative 2x.
That's what I get. Okay? That's still equation 1. It's the same equation. The only difference is as I multiplied both sides of the equation by negative 2.
Okay.
Now I'm going to rewrite equation 2 without changing it. And now notice that if I now add the equations together, I've eliminated x.
Okay.
And this is a key part of the pattern. What I'm going to do is I'm going to create an equation 4 and an equation 5. This is equation 4. And it's going to have no x. Remember, I'm adding these two equations. So there's my equation 4. Now, if I can create an equation 5 that has these exact same two variables, y and z, and no x, then I'll be home free because I know how to solve two equations and two unknowns. These 3 variables are very difficult problems, very time-consuming. They'll never give you more than 1 on a test because they take about 15 minutes to do each. And so let's just work through this to the end. Now, I have to work with my original 3 equations, and I want to work with 2 of them that are not 1 and 2 because I've already worked with 1 and 2. So I could work with 2 and 3, or I could work with 1 and 3. And my goal is to eliminate the x variable again. Okay? Well, notice this time, if I take equation 1, I'm going to work with 1 and 3. Well, let's take equation 1 and multiply it by minus 5. the advantage of that is notice that now I can add 1 and 3 together, and the 5x, the x is going to disappear. Okay, so I'm going to have equation 5, and it's going to be the sum of 1 and 3, my new one. Okay, so when I add minus 5x to 5x, no x's. I got minus 10y plus 4y, that's a minus 6y. And I've got plus 15z minus 1z, that's plus 14z. And 1 and 5 is 15 plus 5, so I got 20 there. Okay?
Okay.
So now I'm down to 2 equations and 2 unknowns. Well, I know how to solve these. In other words, I've already gone through a solution. We'll do it, but once you get down to 2 equations and 2 unknowns, assuming you know how to solve this, I'll be able to solve for one of these variables. Once I solve for one of them, I can solve for the other one by merely substituting what I got for the first one. Once I solve for both y and z, I can then go back and solve for x. So I can get all 3 variables solved for by this technique. Now, let's go through solving these 2, equation 4 and 5. Notice that I cannot either add them or subtract them and have a variable eliminated. But if I multiply the top by 2, and I multiply the bottom by minus 3, I'm going to end up with the same or the opposite coefficients on the y term, and then I'm going to be able to add them together and everything will be copacetic. Now, the reason I number my equations like I'm doing is because you end up with an awful lot of equations on the table, and if you don't want to get confused as to where you're at, it's worth numbering them like this. Notice I'm multiplying the top, everything by 2, and I'm multiplying the bottom, everything by minus 3. Excuse me, that should be a minus 60. Now I can add 4 and 5 together. The y disappears. I get minus 22z equals minus 22. Therefore, z is equal to 1.
Okay.
Once you've solved for one variable, now it's a piece of cake, because now I can go back into any equation I want and solve for the other variable. You can, and by any equation, I mean any equation that has just y and z in it.
Okay.
So, what the heck? Normally I would choose the simplest one. I would take one of these that we started with here. But in this case, I'm going to choose this one right here. Substitute 1 for z, and you get 18y minus 42 equals minus 60. So you get 18y equals minus 18. You get y equals minus 1. So there's 2 of the variables solved for. Z equals 1, y equals minus 1. Now we have to go find an equation that has x, y, and z in it. Substitute those and solve for x. Well, the simplest one I see on this page is that one right there. Okay, well, let's do it. X plus 2 times y is negative 1 minus 3 times z, which is 1, all has to equal minus 3. What is this? This is x minus 2 minus 3 equals minus 3, x equal positive 2. So I have all three solutions. X equal positive 2, y was equal to minus 1, and z was equal to 1. That's how you do 3 equations and 3 variables. Okay? And that methodology exactly is the one you want to use. In other words, you pick a variable, eliminate it, that's equation 4. You pick the same variable and eliminate it, that's equation 5. And then you work with 4 and 5 to solve those two variables. And then you backtrack and solve all three of them once you get the solution for one variable.
Okay. All right, that makes a lot more sense.
Have you had matrices yet?
Sorry, what?
Have you had matrices?
No, I don't think so.
Okay. You'll study matrices. I'm not sure when you'll get to it, whether it'll be Algebra 2 or Algebra 1. But the beauty of matrices, as you can imagine, if I had 7 equations and 7 unknowns, how hard it would be to solve it the way we just did. I would have to eliminate it to 6 equations, and then 5, and then 4, and then 3, and then 2, solve for one variable, go back and solve for all the others. It's a gigantic task. It would take me an hour to do that. Well, matrices are particularly good at solving lots of equations and lots of variables. In real life, if you're dealing with, say, a weather system, you might have 50 equations and 50 variables. Well, you're not going to solve that by hand, and they would use matrices to solve that. Matrices lend themselves to solving lots of equations and lots of variables.
Okay.
Now, more important than being able to solve 3 equations and 3 unknowns is being able to solve 2. So I would suggest we spend the next 6 minutes having you practice solving 2 equations and 2 unknowns.
Okay.
Unless you have a specific problem that you want to go over.
Not that I know. Not that I can think of now.
Let's take this one here. How would you solve these 2 equations and 2 unknowns? And you always want to do it by elimination. In other words, there is another method called substitution. But when your 2 equations are given to you in standard format, which both of these are, where your x and your y terms are on the left and a number is on the right, you generally always want to solve those by elimination.
Okay.
Now remember, I can add or subtract equations. I don't always have to add them. I can eliminate the x variable here by merely subtracting 2 from 1. What do I get if I take equation 1 and subtract equation 2 from it?
So
how many x's do I have?
4.
No, I'm subtracting them now.
Okay, I'm sorry.
In other words, I'm going to put a big subtraction sign there. So I'm going to subtract this term from this term, I'm going to subtract this term from this term, and I'm going to subtract this number from this number.
Okay, so you would have 0 x's.
Okay. How many y's?
We do have 4 y's?
Yep.
Okay.
Equals 1.
Right.
So y equals 1/4. And like I said, once you get one of the variables solved for, it's relatively easy to solve for the other one. Notice that if I go up to this second equation here and substitute 1/4, now that's a very simple one variable equation to solve. I get 2x equal 4 1/4, so x would equal 2 1/8. Okay? So,
Okay.
you can either add or subtract equations. That's an important thing to know. So if you find yourself in a situation where you already have the coefficients are the same, then the best way to solve this is going to be to subtract, because I don't have to do any manipulation at all to subtract. Okay?
Okay.
You change it slightly. What's the best thing I can do to eliminate a variable here?
So,
and there's lots of things you can do. There's not just one correct answer. But there is one quickest answer. In other words, there's a hard way and an easy way to do this.
So would you multiply the upper one by 2?
Okay, that works. That gives me 4x plus 6y equals 10. Let me cross that out so we don't get confused. Now I have these two equations. What am I going to do now?
So it would be if you subtract those, it would be x equals 4.
Make sure which one are you subtracting? Are you subtracting 1 from 2 or are you subtracting 2 from 1?
I'm subtracting 2 from 1.
Okay, if you're subtracting 2 from 1, then you get minus x.
Oh, okay. I'm sorry.
Right? Minus x equals 4, which means x equals minus 4.
Okay.
Okay? So that's fine. Just make sure that if you're going to solve these by subtraction, you know which way you're going. In other words, I could have subtracted 2 from 1. I mean 1 from 2, rather. Notice that if I subtract equation 2, or 1 from 2 instead of 2 from 1, I get x equals minus 4 in one step.
Okay.
Equation 2 minus equation 1 gives you x equals minus 4. And then again, you still have to go back into one of these original equations, actually any of the 3 equations you see, substitute minus 4 for x, and then solve for y. Okay? Matthew, I'm sorry I got to run, but I got a 5 o'clock. So,
Alrighty.
I will talk to you next time.
Thank you for your help.
All right, bye.